Imagine standing at the foot of a broken apartment block after demolition. Around you are slabs, chunks, dust, twisted steel, and enough gray rubble to fill street after street. It looks like the kind of mess that only trucks and landfills can handle. But in China, more and more of that dead-looking concrete is being fed back into the system and used again. What seems like the end of a building can become the start of a road, a park, a wall, or even part of another structure. By the end of this story, you will understand how China is learning to turn one of modern construction's biggest messes into a working supply chain. If this is the kind of hidden engineering story you like, where a city's leftovers become the next big breakthrough, you might want to like the video and subscribe while we get into it. Because this is not just about recycling in a small, polite way. This is about what happens when the world's biggest building boom begins to produce its own mountains of waste. And a country has to decide whether those mountains are a burden or a resource. And once you see the numbers, the scale of the choice becomes hard to forget. For years, the old answer was simple. Tear a building down, load the debris onto trucks and move it out of sight. Dump it, bury it, push it to the edge of the city and pretend the problem is solved. That worked for a while when cities were smaller. Land seemed easier to find and construction moved slower. But China did not build slowly. It built highways, rail lines, subway systems, airports, housing blocks, industrial parks, ports, bridges, schools, hospitals, and whole new districts at a pace that changed the map. Then, time began to catch up. The same country that had built at huge speed also had to renovate, replace, and demolish at huge speed. That is where the waste wave began. Concrete waste is not like a pile of paper or bottles. It does not look friendly. It does not stack neatly. It is heavy, rough, dusty, and mixed with all kinds of other materials. When a building comes down, you do not get clean chunks of concrete only. You get brick, glass, wood, tiles, steel bars, insulation, plastic, wiring, dirt, and sometimes even household waste mixed in. It is like dumping out a giant toolbox, a kitchen, and a wall all at once, then smashing everything together. Before anything useful can happen, that mess has to be sorted. And sorting a mountain is not easy. That difficulty became a real national problem because the volume kept growing. Experts and industry reports have estimated that China's annual construction and demolition waste rose into the billions of tons. Older figures often placed it above 1.5 billion tons a year, with projections reaching around 2.5 billion tons near 2020. Later industry estimates put the total at about 275 billion tons in 2022. Those numbers are so large that they stop sounding real. But think of what they mean in physical space. A city tears down yesterday's buildings while building tomorrow's skyline. Every crane that rises will one day create rubble. Every old district rebuilt creates an aftershock of broken material. For a long time, recycling rates stayed low. Some experts once said the recycling rate for construction waste in China was below 5%. Later reports suggested broader recycling of construction and demolition waste climbed much higher, into the range of about 40% in recent years. Even if that improvement is real, it still leaves an enormous amount of waste handled badly, underused, or dumped. So the question was not whether a few smart engineers could build a machine to crush rubble. The real question was whether an entire country could build the rules, plants, routes, standards, and market demand needed to give old concrete a second life. That is a much harder challenge. The problem starts with trust. People trust fresh stone because they know where it came from. It came from a quarry, meaning solid rock cut from the ground. It feels pure, strong, and predictable. Recycled concrete does not feel that way to most buyers. It comes from old buildings of different ages, different designs, and different levels of damage. It may carry dust, old mortar, or fine cracks from its first life. So when engineers talk about reusing it, everyone wants to know the same thing. Will it be safe? Will it last? Can it carry weight? Can it survive rain, heat, freezing, and heavy traffic? Until those questions are answered with tests and real projects, recycling stays on the edge. Then there is the price problem. Recycling sounds efficient, but the process is not free. Waste has to be collected. Trucks have to move it. Workers and machines have to separate the materials. Crushers have to break it down. Magnets have to pull out steel. Screens have to sort the right sizes. Labs have to test the final product. Land is needed for plants. Permits are needed for operation. Fresh crushed stone from a quarry can sometimes still look easier and cheaper, especially if environmental costs are ignored. So in the early years, many recycling firms faced a painful truth. Even if the idea was right, the numbers did not always work in their favor. Would China keep pushing anyway? It did, partly because the cost of doing nothing kept rising. Illegal dumping ate up land and scarred city edges. Dust and runoff polluted the environment. Good land near growing cities became too valuable to waste on piles of broken rubble. In Beijing's Changping district, officials in Shahe town said demolition and renovation work there was expected to create 2.3 million tons of construction waste by 2020. If that were handled by traditional landfill methods, it would occupy about 15 hectares of land with a depth of 10 meters, equal to around 22 football fields. That comparison matters because it turns a cold number into an image. You can suddenly see the problem, not just read it. Once the scale became impossible to ignore, the logic of reuse became stronger. China did not lack concrete waste. It lacked clean, dependable systems for turning waste into useful material. And that is where the real breakthrough begins. The process is less magical than people imagine. It is mostly careful, step-by-step industrial work. A demolition site produces broken concrete. Trucks carry that material to a temporary sorting area, a mobile plant, or a larger fixed recycling facility. The load is checked first because what comes in matters. Clean concrete is far more valuable than mixed waste. So the first job is not to crush everything. It is to separate what should never be crushed together. Large pieces of steel are removed early. Wood, plastic, and glass are pulled aside. Sometimes workers do part of this by hand. Sometimes machines do more of it. Some plants use sensors to identify different materials. In one report, Jiangsu LVHE Environmental Technology said a facility put into use in Jiangsu province used artificial intelligence sorting technology and could identify construction waste through composite sensors, separating it into 13 to 15 categories by type and size. That might sound technical, but the core idea is simple. The cleaner the stream going in, the better the product coming out. It is like trying to make fresh bread from leftovers. If you separate the usable flour from the trash first, your chances improve a lot. After sorting comes crushing. Massive machines break the concrete into smaller pieces. A jaw crusher works a bit like giant metal teeth. It grabs the material and bites it down into rough chunks. Then secondary crushers break those chunks further. At this point, the goal is not just to make the pile smaller. It is to make the material more uniform. Uniform means more consistent, more alike, easier to predict. A builder cannot work well with a pile where one part is powder, another part is giant chunks, and another part still hides metal and trash. So the crushed material passes through vibrating screens, which are like giant sieves stacked in levels, separating large, medium, and fine particles. Magnets then remove steel fragments left behind. This matters because old reinforced concrete often hides long and short steel pieces inside it. Reinforced means steel bars were placed inside the concrete to give it more strength, like bones inside a body. Those bars were useful in the building's first life, but they can damage machines and ruin new mixes if not removed. Air separation can also help pull out light contaminants such as plastic or paper. Water washing may be used in some systems to reduce dust and remove dirt. What began as demolition rubble is now becoming a set of cleaner material streams, each with a possible next job. But what exactly are those jobs? The most important product is recycled aggregate. Aggregate is the stone and gravel part of concrete. If concrete were a fruitcake, cement would be the sticky batter, and aggregate would be the larger pieces inside it that give it body. Recycled aggregate comes in different sizes. Coarse recycled aggregate is more like gravel. Fine recycled aggregate is more like sand. Once sorted by size and quality, these materials can be used in different ways. Some go into road base, the hidden support layer under roads. Some become paving blocks, curbstones, bricks, or mortar. Mortar is the paste used to hold bricks together, like glue between blocks. Some recycled aggregate can even go back into new concrete itself. But here's the tricky part. Old concrete is not just plain stone. It usually carries old cement paste stuck to the aggregate. That paste has tiny pores, tiny holes, which make recycled aggregate more porous than fresh crushed rock. Porous means it can absorb more water, a bit like a dry sponge compared with a smooth marble. Because of that, concrete made with recycled aggregate can behave differently. It may need more careful mix design. It may not reach the same strength in the same way as concrete made from all fresh stone. Engineers have to measure this, test it, and set limits. That is why standards are so important. Without standards, every buyer has to guess. China has spent years building those standards. Technical documents and local rules have set quality grades for recycled coarse and fine aggregates, along with guidance on where they can be used. Higher quality recycled aggregate can go into stronger products. Lower grades may be better for road bases, fill, or lower strength concrete. This sounds slow and bureaucratic, but it is how a market becomes real. Imagine buying medicine with no label and no dose. You would never trust it. Builders feel the same way about materials. They need to know what class the product is, what performance it can reach, and what jobs it is suitable for. The point of grading is not to make recycling complicated, it is to make it trustworthy. This is also why the smartest recycling systems do not chase one grand promise. They do not insist every broken slab should return as top-grade structural concrete. They look for the best next use for each fraction of the waste stream. A clean, strong fraction may go into new concrete products. Medium-grade material may become road foundation or backfill. Fines may go into bricks, pavers, or other products that do not need top structural performance. That flexible approach matters because it turns a difficult waste problem into a chain of usable outputs instead of one all-or-nothing bet. Once cities stop asking, can all of this become one perfect product? They start making real progress. Policy helped push that progress. In April 2018, China's Ministry of Housing and Urban-Rural Development launched pilot work on construction waste management in 35 cities. That step mattered because recycling plants alone cannot fix the system. There must also be rules for how demolition is done, how waste is sorted at the source, how transport is tracked, where facilities can be built, how dumping is punished, and which public works can buy recycled products. The pilots gave local governments a reason to experiment and compare models. Some cities moved faster than others, but the direction was now clear. Construction waste was no longer a side issue. It was becoming part of city management. National planning backed that up. Under the 14th five-year plan for the construction industry, covering the years from 2021 to 2025, China set green building and waste reduction goals. One target said, building waste at new construction sites should be kept below 300 tons per 10,000 square meters. Another target pushed prefabricated buildings to account for more than 30% of new construction. Prefabricated means parts are made in a factory first and then assembled on site, like using large building pieces instead of making every part from scratch in the open air. That can reduce waste from the start, which means fewer leftovers to recycle later. Good recycling is important. Creating less waste in the first place is even better. Other official plans added more pressure. Industry and policy reports describe targets in places like Henan province, where a circular economy plan aimed for an 80% comprehensive recycling and disposal rate for construction and demolition waste by 2025. Chongqing set long-term goals tied to its broader waste system by 2035. At the same time, China's wider push for zero-waste cities created a helpful umbrella. A zero-waste city does not mean a city produces no waste at all. It means the city is designed to reduce waste, recycle more of it, and bury less of it. Construction and demolition waste fits right into that vision because it is one of the biggest urban waste streams by mass. This is where names and places begin to matter. Beijing, Xi'an, Shenzhen, Suchang, Changzhou, Shanghai, and Nanjing each show a different piece of the story. In Xi'an, the city set up a monitoring platform for the transport and processing of construction waste and planned several new recycling centers while supporting related firms. That may sound less exciting than a new machine, but tracking is vital. When waste is not tracked, illegal dumping is easy. When it is tracked, cities can begin to shape a real loop from demolition site to treatment plant to final product. A smart system needs information as much as it needs concrete crushers. Otherwise, the gray mountain just shifts location and nothing deeper changes. Beijing's Shahe town gave one of the clearest local examples. There, construction waste from demolition and renovation was sent into recycling facilities on site and turned into recycled aggregate. That aggregate was then used as raw material for bricks, mortar, and concrete. And officials said about 95% of the building debris could be recycled and used to pave roads for a new park nearby. It is hard to invent a better symbol than that. Material from yesterday's urban fabric becoming the surface of tomorrow's public space. It is not just reuse in theory. It is a physical loop that residents can walk on. And once one place proves it can be done, others start asking what more is possible. Shenzhen became one of the most closely watched cases because it linked construction waste handling with a larger model of urban innovation. The city was chosen in 2019 as one of China's national zero-waste city pilots. It also explored what the Asian Development Bank described as a site-plant combined mode. In simple terms, that means part of the recycling work is done close to where the waste is created, while larger fixed facilities handle deeper processing and bigger flows. That matters because concrete is heavy and transport is expensive. The closer the loop, the better the economics. A material with low value per ton can quickly become worthless if it has to travel too far. Geography becomes part of the engineering. Xuchang is known for another reason. It experimented with a franchise model for construction waste treatment. That means one operator gets formal rights and responsibilities to handle the system under city rules, rather than leaving the market totally scattered. Changzhou's Wujin district was discussed through a public-private partnership model, where government and companies share roles and risk. These business models sound dry, but they answer a very basic question. Who will actually build and run the plants, and who will make sure the trucks do not just dump the material somewhere cheaper? Recycling does not become normal because the technology exists. It becomes normal when responsibilities are clear, money has a path, and failure has a cost. There's also a market reason China is taking this seriously. One industry report estimated that China's construction and demolition waste recycling market had already surpassed 100 billion yuan in 2020. with some estimates ranging roughly from 65.4 billion to 246.4 billion yuan, depending on how the sector is counted. The same report said China's annual recycling capacity had reached around 700 million tons and included about 200 projects each able to process more than 1 million tons a year. That tells us something important. This is no longer a small experimental niche. It is becoming a real industrial field with scale, competition, and room for growth. And once companies see a stable market, they start investing in better equipment. Real-world proof matters even more than market size. A good idea sounds nice. A working project changes minds. In Shanghai, studies have measured the carbon impact of construction waste recycling and found that recycling 1 ton of construction waste could save about 100.4 kilograms of carbon dioxide equivalent. Carbon dioxide equivalent is just a way to count different greenhouse gases using one common measure. The same Shanghai study estimated that annual carbon saving potential from recycling could rise from around 0.31 million tons in 2022 to around 0.35 million tons by 2031 under current paths, with stronger outcomes possible if recycling systems improve. That shows the value is not only local cleanup. There's also a climate story hidden inside the rubble. Shanghai also offered a practical confidence test. In one circular construction pilot, recycled concrete was reported to remain safe after typhoons and earthquakes, while producing 15.6% less carbon emissions per unit area of building material. That is exactly the kind of detail that shifts the discussion. Critics of recycled material often imagine it works only in easy, low-risk situations. But if a pilot can face rough weather and serious stress without failure, the material begins to look less like a compromise and more like a useful tool when applied in the right way. And that is the key phrase, in the right way. Recycling is not about pretending all materials are equal. It is about matching each material to the right job. There's another powerful reason this story matters so much in China. For decades, China consumed close to half of the world's aggregates, meaning sand, gravel, and crushed stone used in building and infrastructure. According to a Tsinghua University-led study later published in Nature Communications, China's aggregate demand peaked at around 18.8 billion tons in 2015. That is a number so large, it barely fits in the mind. The same study developed a model called CHAMPS, which tracked aggregate supply and demand across China's 31 mainland provinces from 1978 to 2050. The researchers found that demand had likely already peaked and could fall to between 9.2 and 12.4 billion tons a year by 2050. But the bigger twist was on the supply side. The Tsinghua team projected that recycled aggregates could rise from about 4% of total supply in 2021 to 48% by 2050. In some provinces, recovered aggregates could meet up to 65% of demand. The study also suggested recycled aggregate could supply as much as 83% of infrastructure aggregate demand by 2050 and around 26% of building aggregate demand. Those numbers do not mean natural stone disappears. They mean the balance could shift in a dramatic way. The leftovers of past growth could become one of the main material sources for future growth. That is not just recycling. That is a new material geography. So what does that change beyond construction sites? First, it changes pressure on landscapes. Natural aggregates do not appear by magic. They come from rivers, quarries, and mountains. Quarrying means cutting and blasting rock from the earth, then crushing and hauling it away. It uses energy, creates dust, and changes landforms. In some places, sand and gravel extraction can damage rivers and nearby ecosystems. China has already shifted a great deal from natural river sand toward crushed stone and manufactured sand, but that still means more mountains are cut and more transport is needed. Every ton of recycled aggregate that can replace fresh extraction eases some of that burden. On the scale China builds, even a small percentage shift becomes enormous. Second, it changes how cities think about their own metabolism. Metabolism is a word borrowed from biology. It means how a body takes in resources, uses them, and gets rid of waste. A city also has a metabolism. Raw materials come in. Buildings and roads go up. Waste goes out. A wasteful city acts like a body that throws away too much nutrition. A circular city tries to keep useful material moving in loops. Old structures become resources for new ones. Distances shrink between demolition, processing, and reuse. Waste becomes local stock instead of dead burden. That way of thinking is powerful because it changes urban planning from a straight line into a circle, and circles can be more resilient than lines. Resilience is another big part of the story. A country that depends only on fresh raw material is more exposed to price swings, supply restrictions, transport costs, and local environmental conflict. A country that can recover a large share of material from its own old buildings gains another source of supply. It is like having savings instead of living only from one paycheck. Recycled concrete will not replace all material needs, but it can soften shocks and stretch domestic resources further. In a world where supply chains can be tense and environmental rules can tighten fast, that matters. Material security may sound dull next to flashy new technology, but it shapes what a country can build and how steadily it can keep building. The benefits also show up at the neighborhood level. When recycling is done near demolition sites, cities can reduce truck trips to far-off dumps and quarries. That means less fuel burned, less traffic, and less dust moving across long distances. Mobile crushing equipment or temporary site-based systems can help here. A mobile plant is basically a processing line that can be moved close to where the waste is created, instead of forcing all waste to travel to one distant factory. Not every site can use such a system, but where it works, it can cut costs and keep the loop local. This is one reason China's site-plant combined models are so interesting. They adapt the process to the city instead of forcing the city to adapt to one rigid process. Still, it would be a mistake to tell this story as if the hard part is over. Recycled concrete has limits, and the people working in the field know it. Quality varies. Fine recycled aggregates can be especially tricky in higher-grade concrete. Old cement paste on the surface of aggregate can increase water demand and lower performance if not handled carefully. Some structural applications remain more conservative for good reason. Pre-stressed concrete, very high strength members, and projects with very long design lives may require stricter limits or fresh materials. This is not a failure of recycling, it is reality. Honest material science is what keeps public trust alive. If advocates overpromise, the whole field can lose credibility fast. Profit is another challenge. Xinhua quoted Jiangsu LVHE's manager, saying it was still hard to make profits from recycling construction waste and that companies partly relied on government subsidies because disposal and recycling costs were high. That one sentence says a lot. Even when the technology works, the business model can remain thin. Illegal dumping can undercut honest operators. Land for plants can be expensive near cities. Testing and compliance add cost, though they are necessary. Markets for recycled products may be weaker than markets for fresh materials unless public projects help create demand. So this is not a smooth gold rush. It is more like building a new industry brick by brick, while old habits still pull in the other direction. Distance remains a stubborn problem too. Concrete is bulky and heavy. Its value per ton is not high enough to survive endless transport. If a demolition site is far from a recycling plant, or if the final buyer is far from both, the economics can fall apart. That is why mapping and logistics matter so much. A good recycling system needs the right plant in the right place, serving the right cluster of demolition and construction activity. It is not enough to build a giant facility and hope the material finds its way. The route has to make sense. In that way, recycling concrete is as much about city design and transport planning as it is about crushers and screens. There's also the issue of public confidence. People do not worry about what lies under a road until a road fails. They do not think about the aggregate in a wall until cracks appear. That means recycled materials must prove themselves again and again. Public works can help because they provide controlled, visible test grounds. Roads, park paths, pavements, curbs, and municipal works are often good early use cases. Once those perform well, confidence spreads. Then more demanding uses can expand under standards and testing. The pattern is familiar in engineering. First comes skepticism, then pilots, then rules, then routine. China is somewhere deep in that transition now, but not at the end of it. Timing also gives this story a strange twist. A lot of China's great building boom is still relatively young. Many structures built in recent decades are still in use and have not yet reached the end of their design life. That means the future stream of demolition waste may grow even more as these buildings age, are renovated, or are replaced. In other words, the biggest supply of recyclable construction material may still be ahead. That sounds alarming if the country is unprepared, but it sounds promising if the systems are built in time. China is not just cleaning up an old mess. It is building the machinery, rules, and habits that may be needed for an even larger wave of recoverable material in the decades ahead. That future matters outside China too. Many developing countries are still in earlier stages of urban growth. They will build fast, then face their own demolition cycles later. If China can show that large-scale construction waste recycling can work across major cities, under real market pressure, and within broad policy frameworks, others will study the model. Not every part will transfer directly. Land prices, labor costs, building styles, and regulation differ from country to country, but the core lesson could travel widely. Demolition waste is not just trash to hide, it is delayed supply. And the sooner cities understand that, the less wasteful their future growth may become. There's also a geopolitical angle, even if it stays mostly in the background. Countries compete through productivity, infrastructure, cost control, and supply security. The more a nation can reuse its own material base, the less dependent it becomes on continuous fresh extraction and long transport chains. That can matter during shortages, price spikes, or tougher environmental rules. Recycled concrete alone will not decide global competition, of course, but it sits inside a bigger contest over who can build modern cities and infrastructure with fewer losses, lower emissions, and smarter resource loops. In that contest, the most powerful breakthrough is not always a new gadget. Sometimes it is a better system for handling something the world used to ignore. What makes the Chinese case so striking is how ordinary the moving parts are. There is no fantasy machine that turns dust into skyscrapers in one pass. There are trucks, magnets, crushers, screens, standards, contracts, plants, inspections, subsidies, procurement rules, and city pilots. It is practical work, sometimes messy and uneven, but very real. That is why it deserves attention. Grand change often hides inside unglamorous systems. The world notices the tower once it rises. Few people notice the waste stream that made the next tower possible. Yet that hidden stream can shape land use, energy use, local pollution, material costs, and climate impact all at once. That is a lot of power hiding inside rubble. And maybe the deepest change is mental. Most people think of concrete as final. Once it hardens, it feels permanent, like the story is over. But that is only true if we choose to end the story there. In practice, concrete can live several lives. It can stand as a building, then fall as rubble, then return as road base, pavers, bricks, or part of another structure. Not perfectly, not forever, but enough to matter. Once you see that, demolition stops looking like pure loss. It starts to look like a form of harvesting. A harsh, noisy, dusty kind of harvest, yes, but a harvest all the same. And that changes how a nation can think about the material world it has already built. So the real breakthrough is not that China discovered rubble can be crushed. People have known that for a long time. The breakthrough is that China is building more complete loops around that idea. It is connecting demolition sites to treatment systems to standards, standards to public projects, and public projects to a broader push for lower waste and lower emissions. It is turning a gray, ugly afterthought into a supply chain. Step by step, city by city, and ton by ton, the mountain is becoming material again. That is the core of the story. China is learning that the remains of growth do not have to be buried as a problem. With enough sorting, testing, planning, and trust, they can be brought back as part of the solution. One generation of concrete can help build the next. If you want more long-form stories where hidden systems shape the future in ways most people never notice, like the video, subscribe, and turn on notifications so you do not miss the next one. And tell me in the comments, if your city started recycling demolition waste at scale tomorrow, where do you think that reused concrete should go first? Roads, parks, public housing, or major infrastructure?